So, greetings, students. Welcome to today's lecture. So, in today's lecture, we'll be dealing with your cathode ray oscilloscope, which is nothing but the CRO. So, we'll be seeing about the working principle. Okay, we'll be seeing about its working principle. Okay, so and the construction also we'll be seeing. Okay, so where your CRO will be used. Okay, your CRO will be used in practical application as well as for your measurements. Okay, it will be used mainly for your measurements. So in your measurements, in the sense, in order to find out the waveform. Okay, to measure the waveform of the particular quantity, they will be making use of your CRO. Okay, so apart from this, the CRO you can also see in your olden days TV. Okay, televisions you can see. So there will be the cathode ray oscilloscope for your picture representation. Okay, so over there only the screen will be connected, and over there only it will be visible. Okay, so that is the behind your screen there will be a cathode ray oscilloscope in your with respect to your olden days TV. Okay, so this is one of the practical application. So moving on. So the working and applications is the main thing what will be covered in this lecture. Okay. So generally the CRO stands for your cathode ray oscilloscope. So in modern electronics, the CRO plays an important role in your electronic circuits. So it is the components basically can be divided as your vertical controllers and horizontal controllers, and then the triggers. So as I said, there will be a display, and the display will be controlled by these two controllers. Okay, so most of the oscilloscopes are used for the probes. They are used for input of any instrument. As I said, they will be also used for the measuring your any electrical quantities. We can analyze the waveform. Okay, how we can analyze the waveform lessons by plotting the amplitude along with the x-axis and the y-axis. So this is your x-axis and this is your y-axis. If you are plotting across your x and the y-axis the values, it is possible to get your waveform. Okay, so what is a CRO? We have to know. So a CRO is an electronic test instrument. It's an electronic test instrument. It is used to obtain waveforms when different input signals are given. So the input signals need not be the same. Even for different amplitude and different magnitudes and different phase, it is possible to find your waveforms. Okay, so generally it is also called as oscillograph in your early days. The oscilloscope observes a change in the electric signal over the time. So this is the main important point you have seen. What is generally an oscilloscope they are asking means it's nothing but it observes the changes in the electrical signals with respect to your time. Okay, with respect to your time. Thus, the voltage and time describe the shape. Okay, it is continuously graphed beside the scale. So this is the what the CRO does. Okay, by seeing the waveform, we can analyze some of the properties like amplitude, frequency, rise time, distortion, time interval. So these are the characteristics of your waveform. Okay, these are the characteristics of your waveform. So this is how your CRO looks like. So you might have seen in your laboratories. Okay, so there'll be adjustment. So these are the adjustment area. Okay, so here you will be connecting your probe. So it is a the two channel CRO. It is a two channel CRO because two of the channels it is possible to connect. So here you can see it is a primary, it is a secondary channel. So coming to the block diagram, this is a very important part of your CRO. So at first what happens is that your input signal will be given. So where it will be given means your input signal is nothing but the measured quantity. Okay, you can have the quantity which is to be measured. Okay, for example, you can have a voltage. Okay, first the voltage will be given, but the magnitude of the voltage initially will be very low. It will be very low. Why in the sense means it will has to cross the transformers and that is your potential transformers and your resistors. After that only it comes to this vertical amplifier. So hence this voltage has to be what you have to say. It has to be enlarged, or the magnitude has to be increased for this voltage. So we'll be making use of this vertical amplifier. So from this vertical amplifier, there goes two parts. Okay, one is to a delay line, that is a delay circuit will be used, and another one is to a trigger circuit. Okay, so this is the main two things what you have to consider. So from the delay line, it will be given to the vertical deflection paths. Okay, so we can take these plates as your y1 and y2 plates, and these from this it will be coming to a trigger circuit. Okay, so from there will be a time based generator. So as I said, your y-axis will be of your amplitude. Okay, that mainly your voltage, and your x-axis will be of that your time period, which is your t, or t, which is represented in seconds. So for the x-axis, you have to have a time generator. Okay, so after this time generator, it will be again given to the horizontal amplifier, and this you can take it as x1 and x2. And finally, this is your screen. This is your screen. So what happens is that according to the signal, as per the signal received, your delay line signal will be given, and your time-based generator also works. So based upon these two, there will be the display. How means the electron gun liberates the electrons. Okay. So it starts to move from this side, this A point. Okay. So B point is what your screen. So it starts to move from A and finally it has to reach the B. In between this A to B, what happens is that this electrons gets deflected by this vertical deflection plate and this horizontal deflection plate. Okay. For example, if this is what your deflection plate in the sense, vertical deflection plate in the sense, so you can take y1, y2. So if the electrons coming over here means at a particular time period, this will be of a positive electron and this will be of a negative electron. So generally what happens is that your electron is of your negative value, right? So this negative electron gets repelled from this negative electrode and gets attracted towards this positive electrode. So the direction just deviates from its straight path. Okay, this is what with respect to your vertical deflection. The same thing is similar to that for your horizontal deflection also. The horizontal deflection also works similar to this manner. So hence, based upon the signal generated from here, delay line and your time-based generator, the electrons from the electron gun gets deflected. So as per this, when it reaches the screen or the B segment, what happens is that as per the deflections, the electrons will be visible. So hence you will be getting a waveform like that. Okay. So this is the block diagram and the working of your CRO in short. Okay. So coming to the block diagram of the CRO, the CRO recruit the cathode ray tube and act as a heat oscilloscope. Okay. In an oscilloscope, the CRT produces a electron beam. So as I said, electron beam which is accelerated by to a high velocity. The electron beam is of a very high velocity when compared to the normal electrons. Okay. So generally, it brings to the focal point on the fluorescent screen. Thus, the screen produces a visible spot where the electron beam strikes by detecting the beam above the screen. So, as I said, there will be the deflection So at the end of the deflection only you will be getting the result over the screen. Okay, electrons can act as an electrical pencil of light. Okay? So to complete the task, we need various electrical signals and voltages. This is provided by power supply circuits of the oscilloscope. It can either be of high voltage or the low voltage. So high voltage will be mainly used for a CRT tube to generate your electron. Okay, to generate your electron. Low voltage is used for your other circuits. Okay, so then the normal voltage supply is necessary for control units. So the horizontal plates are placed between the electron, thus it can deflect the beam according to the input signal. So this is what I have said. So just before detecting the electron beam on the screen in horizontal direction, a constant time-dependent time-based generator is given. So based upon this time generator only, your x-axis is involved. Okay. So the signals will pass from vertical deflection plate through the vertical amplifier. It can amplify the signal to a level. Okay. If the electron beam is directed in the x-axis and y-axis, a trigger circuit is given for synchronizing these two types of. Okay. So mainly why we are giving here the delay circuit as well as this trigger circuit in the sense mainly for synchronizing purpose. Okay. So it has to be the in sync. So hence you can get the waveform or the display in the screen. So this is a working they have already we have discussed the same working they are given in this diagram. So the main function is to amplify the big signal mainly by the amplifier. So amplifier signal can produce the display signal. To examine the input signals are penetrated through the vertical deflection. A number of amplifying stages can be included. So if you are before sending into your deflection system, it has to be the signal has to be very strong. Okay, so it is one of the important criteria. So coming to the horizontal deflection system, vertical and horizontal system consists of horizontal amplifiers. Okay, to amplify the weak input signals. But it is different from your vertical deflection system. Why in the sense means here we are talking about your time base. Okay, so there are four types of sweeps. So generally, what a sweep is that the sweep voltage is nothing but it is a kind of a magnitude that is, helps in generating your time base. Okay. So generally, this sweep is of four types: recurrent sweep, triggered sweep, driven sweep, and non-sawtooth sweep. So here they have explained about the various sweep. Okay. So here in the recurrent sweep, the sawtooth is respective. That is a new sweep. Okay. So here the input signal, if it is periodic, means the sweep repetition rate can be adjusted. Okay. So in the trigger sweep, here you will be making use of some trigger circuits. So driven sweep, so non-sawtooth sweep. Okay, synchronization. This is an important one. Synchronization is done to produce stationary pattern. After synchronization only, you will be getting stationary pattern. So synchronization is between the sweep and the signal. Okay, there are some sources of synchronization which can be selected by the synchronization selector. So internal, external line. So these are all the basic things you can study with respect to your CRO. So this you can see. So coming to the application, so main application is about your voltage measurement, current measurement. So the waveform inference. So measurement of phase and frequency. These are the things you can measure using your CRO. So users can display different types of waveform. Can measure even short time interval. So in voltmeter, you can measure your potential difference. Okay. So this is a conclusion of your CRO. Okay. So with this, I think we can complete your lecture also. Okay, so thank you.